All right. Aaron, you want to read the first one?
Yeah. Students will go over the interview problems after you try it on Thursday.
Yeah, so I broke down the second one a lot, and we'll go through the thought process behind it. And then number 2, let's go to Qua.
Students will use props in React.
Excellent. So we're going to go over props in React, how to display images, and put on-click events on images, and then we'll start our homework later on in class, right? No more homeworks, so you can focus on your projects, right? Because you're all focusing on your projects. And 3, let's go to Derek.
Students will go over the backend Express API for a full stack React app.
Yeah, so we're going to go over just a Mongo API. It's just Express in Mongo.js, and all the routes for it. And then I'm hoping we get to this part, but if we don't, we'll push it to Tuesday. That's fine. Rob?
Students will go over part of the front end for a full stack React app.
Yeah, so we're going to be building a full stack React app. So it's going to have, it's an Express backend, right? It's going to have authentication using JWT tokens. And we're going to build the whole front end in React, including the login system. And then we're going to build the React Native part to it. And then we're going to refactor it to use Redux later on, which is a state management library that is used a lot in the Bay Area. And then the last one, let's go to Nick.
Students will start on their first React homework.
Yeah, so this is less important than this right here. So I'll just be keeping an eye on time. So I'm going to just open up O2 Powers. You guys should all have this, right? Because you unzip the folder right here, class code. And right here, what does line 5 do? Let's go to Rob. Rob's row. Yeah, exactly. You're right. Right. I'm with console log, you can print out a string, comma, something else, or you just keep putting commas and then print out a bunch of things. So it just says it's going to print out 3 times 3 is what, Rob's row? No, nice, right? So we're just gonna I'm gonna break these things down because a lot of these things we're gonna use in these concepts we're gonna use in the next files. And over here, what does this do right here? And I feel like I screwed this up. There should have been an extra parenthesis right there. That's okay. Yeah, I was missing a parenthesis right here at the end of line 11. That's okay. What does this code do right here? Let's go to Sandy's row. Excellent. 3 to the second power. So what's 3 to the second power? 9, right? So this 3 to the second power is just 3 times 3, right? 3 times 3. And then over here, what's going to print out over here? Let's go to Derek's row.
27.
27, right? So we're just printing out the string 3 times 3 times 3. And then we're printing out the execution of it, which is 27, right? 3 times 3 is 9, 9 times 3 is 27. And then what about this, Aaron?
It's doing the powers up. So instead of multiplying by 3 times, it's just doing 3 to the power of 3.
Excellent, right? So it's doing 3 to the power of 3. And what is 3 to the power of 3? Good. 27. Nice. Yeah.
Sorry.
That's okay. Right. 3 to the power of 3 is just 3 times 3 times 3. Right. And that's how it works for all the powers. And over here, right, what this just prints out what? 3, right? It's going to print out the string 3, and it's going to print out 3 right here. I guess this is a little redundant, but just sticking with consistency. And this is going to be math.pow 3 to the 1 power. So what is 3 to the 1 power, Nick?
0.
Well,
3.
3, yes. Yeah. I was about to say something else is 0, but I can't think of it.
Yeah.
But this is 3, right? Anything to the power of 1 is going to be itself, right? Because it's like you're just multiplying 3 no times, right? Just 3. And then over here, anything to the power of 0 is 1, right? So over here is 3 to the power of 0 is 1. And this is a weird concept. I remember, like, I was a math tutor.
Sorry if I grab my class because sticky notes.
Yeah, totally.
I'm so sorry.
Oh, no, I didn't even know they were there.
Thank
Cool.
you.
Oh, man, could have used them. So you start off with 9 divided by 9, right? And this is what I did in my higher level math classes. But this isn't a complete proof. So 9 divided by 9 is what, Nick? 1, right? Anything divided by itself is 1. So another way of representing 9 divided by 9, right, is 9 times 1/9. Right? 9 times 1/9 is also 9 divided by 9, right? I guess I could put an intermediary step right here. 9 over 1 times 1 over 9. Right? 9 over 1 times 1 over 9 is 9 divided by 9. That's another way of representing it. And then over here, right, I can take 9, and 9 is just 3 squared, just like we did above, right? 9 is just 3 squared. And then 1/9 is just 1, the 1 stays there, right? The 1 stays. And you could just represent the 9 by 3 squared. By 3 squared, right here on the bottom. And anytime you have a number to an exponent on the denominator, if you bring that number to the top, to the numerator, the exponent becomes negative. So this right here is just 3 squared times 3 to the negative 2 power, right? 1 over 3 squared. In other words, 1 over 9 is just 3 to the negative 2 power. And this is the case for any number that is on the denominator that you bring up to the numerator. And you can add exponents. So 3 squared times 3 to the negative 2 is actually 3 to the 2 plus negative 2 power, which is 3 to the 0 power, right? And this has to be 1, right? This has to be 1 because 9 divided by 9 is 1. And we just re-represented this whole thing, right? So this is kind of what you do in higher level math. You just kind of like, they ask you to prove something and you kind of go through this process. Although this isn't a complete proof, this would probably get me a 0 because I didn't do everything appropriately, but it makes sense now, I think, kind of. Go ahead. Yeah. So the most important thing to take away from this is 3 to the power of 0 is what? 1, right? What about 10 to the power of 0? 1, right? What about 100 to the power of 1? 100. Okay, so just keep that in mind moving forward, right? Okay, so now we're going to go into the next file.
Quick question.
Yes, Nick.
Inductive or deductive proof?
You know, I got C's in my classes.
Okay. Curious.
I was the dumbest kid in my class.
Inductive.
So we did a lot of this on Thursday, but we should go over what it means, right? Math.log1010. So when you do math.log10 when you're passing in the value 10, you're saying 10 to the power of blank gives you 10, right? What this prints out on line 2 is 10 to the power of what gives you 10. And yeah, exactly, 1. 10 to the power of 1 gives you 10, right? And then over here, if you pass in 100, it's 10 to the power of what gives you 100 too, right? And then over here, 10 to the power of what gives you 1,003, right? Because 10 times 10 times 10, here, let's write this out. 10 times 10 times 10 is 1,000, right? 3 tens gives you 1,000. Over here, 10 times 10 is 100, right? 2 tens gives you 100. 1 10 gives you 10. Questions on this right here? We use it a lot on Thursday, so figured we should just understand what it does. Yeah, Sandy.
Do math.log 5 or does it have to be 10?
Yeah, it's always the log is always 10. Yeah.
Log 2.
Log 2. Is that E?
I don't know, but log 10 is just a function.
Log 10. Oh, I guess.
Of the math library. But there does exist a log 2 as well.
Oh, okay, cool.
So you know,
All right. So you could
in the math library.
can you use math.log 2?
Yeah, I think so. It's just that I saw it in the documentation.
Well, it's good to know. Hold on. Log 2, if I put 8 here, it should give us what? 2 to the power of what gives you 8? 3. So hopefully it gives us 3. It does. All right, cool. We have it. I wonder if you can just put any number there. This should give us 2. Nope. Okay. What other logs do we have? Just so.
There's 10E, there's 2E, there's 1P.
I don't know what that means. Okay, well, we have 2, so that's good. Just so you know. All right, so using all of this stuff right here, we'll get the digit of a number without converting it to a string, right? So we're going to go over the second problem now. So let's say n, we have a variable n, it's a let, right? So the reason why we're doing lets is we're going to just stick with ES6 now on. There is no, what's the thing called where it's undefined above? Oh my God. No, sorry, Nick. Wait, what was the thing?
Where it's undefined above?
You declare var A equals 5, but above A, it's undefined. A is undefined. There's none of that with when you use let. Man, what the hell's that called?
Temporal dead cell.
What?
Temporal dead cell.
Temporal dead cell?
Dead cell. Zone.
I don't think so. I think it's like something else, right? Yeah. Okay, it doesn't matter. All right, 4321, that's n, right? If we want to get the first digit of 4, right? If we want to get this 4, we could do math.log 10n, right? And do math.ceiling of that, right? So let's go over why that worked, right? So math.log 10n gives us 3.635 whatever, right? Because it's 10 to the what power gives you 4321. That you can't really do that in your head, but it gives you a number 3. It's not going to be 4, right? It cannot be 4. Why can this blank not be 4 or more? Why can't math.log 10n right here cannot be 4 or more? Because it'll give you a 5-digit number, right? And so why can it not be 2 or less? Exactly, right? 2 is 100, right? Or less. So it has to be over 3, because if it was just 3, then if math.log 10n gave you 3, what's the value of n? 1,000, right? If math.log 10n gave you 3, then it's 10 to the what power? It's 10 to the third power, right? Which is 1,000. So it has to be between 3 and 4. Math.log 10 has to be between 3 and 4. And if we're doing math.ceil, it's always going to go all the way up. It's going to go all the way up. So this is how we can get 4 digits, right? Num digits gives us 4. And I'm sorry if I alluded that this was getting us the first digit. I just completely was wrong, right? We're getting the number of digits here. This is how we get the number of digits. Questions on this? This alone could be a flashcard for you, right? This alone will save you on tons of problems on LeetCode, right? Being able to get the number of digits without converting the number to a string and getting the length of it, right? Because if they say don't convert the number to a string, you can't do that then, right? So this is the only way to do that, right? But you just have to think about the logic behind it, and then you'll be able to solve a ton of other problems with this type of logic, right? Because 10 squared is 100, 10 to the third is 1,000, 10 to the fourth is 10,000. So for 4321, the log of that is going to be 3 point something. Okay. So all of the following ways of getting the digits here work, but they're not consistent. They're not consistent. And consistency is important when you're solving problems on LeetCode or on interviews, because without consistency, you can't keep it inside of a loop. You can't keep doing it for the first digit, the second digit, the third digit, the fourth digit, right? Because we saw that on Thursday where I was putting if statements, right? I had an if statement for the first digit, I had an if statement for the second digit, if statement for the last digit, the third digit. It's not going to work, because what about 100 number? What if the number was 100 digits long? I can't keep adding if statements, right? So we have to come up with a way that works for everything. But first, you just try to come up with a way that works, right? So over here, we came up with this on Thursday, where for the first digit, you do the number divided by math.pow 10 to the num digits minus 3. So num digits is what? Kuthika, cool, 4, right? 4 minus 1 is what? 3, right? So math.pow 10 comma 3 is going to give us what? 1,000, good, right? So we do 4321 divided by 1,000. That's going to give us 4.321, right? And we take math.floor of that, and that's going to give us just 4. And that consistently will give you the first digit. That will consistently give you the first digit right there. And I'm actually going to not go over the rest of this right here, because it's a little confusing. But over here, I have a way to get the last digit right here, 1. I have a way to get the second digit. So all of this work right here, all these lines right here gets me the second, gets me the second to last digit. And then this right here gets us the second digit right here, right? So I'm not going to go over this because there's no, we can't do this process inside the for loop. It has to be the same every time. So let's just take, so what I did was I took this line right here on line 29, right? This line 29, because it makes, like, what if we can modify this in a way that works for the second digit, right? What if we could just slightly tweak it to make it work for the second digit? So let me just get the number so we know what. So over here, let me just put n is 4321. I'm not going to redefine it because it's up here, right? So over here, we have, it's the same thing as above, right? Math.floor n divided by 1,000, but we're going to modify 10. And then over here, we have the second digit. It's the same thing, but instead of the 1, minus 1, instead of the minus 1, we're going to minus 2. And for the third digit, we're going to minus 3. And for the fourth digit, we're going to minus 4, right? But how do you come to this? How do you come to this conclusion right here? So I wrote out that process right here. Right? We had this. We came up with this on Thursday, right? After some trial and error, we came up with this thing in the Node console, right? By just like trying things. We just came up with this, right? And this gives us 4 right here. It gives us the first digit. And for the second digit, I try to modify this to just manipulate it a little bit. So what I did was I just instead of subtracting 1, I just thought, okay, if I wanted the second digit, maybe if I subtract 2, right? And when I subtracted 2, what I ended up getting was 43. I got 43, not 3, right? Because I want the second digit. The second digit's 3, not 43, right? So how do I get 3 from 43? Well, I can mod it by 10. If you take this number 43 and mod it by 10, it's going to give you the last digit. Whenever you mod something by 10, it's going to give you the last digit. Why? Because it checks how many times 10 can go in, right? 10 can go, how many times can 10 go into 43, Rob's row? 4, right? And 10 times 4 is 40. 43 minus 40 is 3, right? So 10 goes into 43 4 times, and there's 3 left over, right? So whenever you do mod 10, it's going to give you the last digit. So we modded 10, and then that gives us the second digit, right? We subtracted 2 and then modded 10. And then I realized, well, I can't just mod 10 for the second digit. What if I could just mod 10 here too? Because whenever you take any number modded 10 will get you the last digit, even if that number is less than 10, right? 3 mod 10 will give you 3, because 10 goes into 3 how many times? 0. What's left over? 3. Right? So 5 mod 10 is what? 5, right? 7 mod 10 is what? 7, right? Because 10 goes into 7 0 times, and 7's left over, right? So for the first digit, right here, you could actually just do the same thing, right? This will actually get you 4. We just mod it by 10 to be consistent, right here. So I'm just showing you the thought process. This is what I actually on Thursday. This is what did we do? I did this, and it just doesn't work because it isn't consistent enough, right? We can't use it over and over again. Whereas this right here, right, all you have to do is change this number. First it's -1, then it's -2, then it's -3, then -4, then -5, right? If I want this 6 digits, -6, right? That's it. So we can consistently use this inside of a loop to get the digits. Cool. Questions on this? I'm going to give you time to look it over. There's no easy way to just be good at these problems other than just doing them a lot. You just can't. There's no way. You just have to be doing them a lot. And, just turn on whatever TV show you like, right? And then just go on LeetCode and do these problems, right? I'm serious. Like, if you can zone, and then you'll be thinking about these problems later on too, right? You'll be thinking about ways of solving them when you're not at your computer, but you got to be doing these a lot. The Bay Area is notorious for, yes, you can do everything we need you to do, but can you do things that you'll never ever do, right? Because if you want to join our club, you got to be able to do these problems, right? So you're going to have to get good at these problems to get a job here, right? Not in New York, though. New York doesn't care, right? Because I didn't know how to do any of this stuff, and I got a job. Yeah, so how would we solve that palindrome problem? Right here, let me see if I can do this right here. So this is how we got the digits, right? We have our function name. The function name is what? What's the function name, Judika? Is palnode, right? How many arguments is it taking, Nick?
One argument.
One argument, the number, right? The number. And over here, this is going to get us the number of digits. We talked about this, right? So the number 4321, right? If it was 4321, it's between 100, it's between 1,000 and 10,000. So what math.log10 is going to give us is 3 point something. We take the ceiling of that, it's going to give us 4. That's 4 digits for 4321. It's always going to work, this line right here. And then Kwa showed me his way of doing things. On Thursday, what he did was he took the number of digits divided by 2, and he floored that. and that's the number of times we have to loop. So why is this the case? Why is this the number of times we have to loop? Well, if we take a look at our input and output right here. So if let's say 1, 2, 1, what do I have to check here? I have to check the first number is equal to the last number, right? The last digit. I'm sorry, the last digit. And then do I have to check the middle number? No, right? Because it's just there, right? It's 1, 2, 1 is a palindrome, and all we have to worry about is this first number and the last digit, right? So in all, we just had one check. But let's go 1, 1, 2, 1, 1. Or let's try a different number. 3, 3, right? So over here, we have to check if the first digit is equal to the last digit, and we have to check if the second digit is equal to the second to last digit. And that's it. We don't have to check the middle. We don't have to check that middle 2, right? Because it's just there. And so we're doing 2 checks. And if I do 1, 5, 5, 1, it's the same deal. We're just doing 2 checks, right? So this is the length of this is 5, right? 5 divided by 2 is what? 2.5, right? Math.floor of that 2.5 is 2. And over here, it's the same deal, right? For this one, 3 divided by 2 is what? 1.5, and math.floor 1.5 is what? 1. Okay, let's do the same thing over here. 4 divided by 2 is what? 2. And math.floor of 2 is what? 2. So we could just do math.floor of the number of digits divided by 2 because of this right here. And you're not going to you're not going to realize this. There's no way to realize this without writing out the numbers, writing out input and output, right? Like 1, 2, 1 gives us how many digits? I mean, how many loops do we have to do? How many checks do we have to do for 1, 2, 1? How many checks do we have to do for this, right? You have to write this out to kind of make that realization. And you have to get used to that. You're used to doing that when you're doing these problems, right? Because imagine you're on your interview, you've done 100 leak code problems, and there's a leak code problem that shows up that you've never done, and every single part of it is something that you've never done before, right? How are you going to be able to do it on the interview unless you've just practiced just writing things out, looking at them, and just making observations? If you practice that on every leak code problem, being able to make observations, right, then you'll do fine on your interview, right? Because you've just been practicing just making observations, right? Like you're just this, like you have to think of yourself as this, I can't say the word, detective, right? Because a detective, although like many cases are going to be similar, right? Some cases are going to be different, but they still, I guess, not here, but in other places, they solve their crimes, right? By using the stuff they learn in school. Go ahead, Kwa.
I think there's one edge case to this, and it's 10. I think you need like 2.
Oh, really?
Or log of 10 or whatever it breaks. Yeah. So
10, well, 10 will give you the number of digits, right?
right. Well, I just ran that file with 10 and it came out true.
Oh, because 10 will give you
Yeah.
1.
Yeah.
Okay, wow. That's so interesting.
I think that's the only other.
That's the only edge case? Okay, thank you. Let me just write that down. So I'll just write if n equals 10. Yeah. What do you mean return false? Oh yeah, you're right. I was gonna let it just do the entire thing.
Why wouldn't it return false?
Oh, it's not a palindrome. So Quad just said that this is the one case where it won't work. The reason why is because the number of digits for 10, right? Math.log 10 will give you what? 1. Math.ceiling of 1 is 1. So num digits will end up becoming 1 instead of 2 in that one case of 10, right? Kind of annoying, but that's the one case right there. What about 1?
I think yeah,
One's also an edge case, right?
yes, it's always different.
Damn it. If n equals 10 or 1,
I think your thing already works for it.
does it work for 1?
I think, well, you have a number 2 test case at the bottom, and it returns true.
Okay, interesting. Cool, thank you. Right, because the num digits will give you 1 instead of 2, right? For this scenario, so we got a return fault. Thank you, Kwa. Appreciate that. Right, so that's why we do time. That's why this is there, right? To get the number of times we loop, the number of checks we make, and I should change this to num checks or digits to check. Hold on one sec. Digit pairs to check. Just want to be super accurate with the names. Okay, so now we do our for loop. Now we're doing our for loop. So we're basically just doing what we did before. See right here? This is very similar to what we did before in the previous file, right? The one thing is we have to check the current digit, right? Imagine the number right here is 4321, just like before, 4321, right? So this first digit has to give us 4, and this last digit has to give us 1. So over here, I'm doing math.floor n, which is 4321, right? Just say n equals 4321, divided by math.pow 10 to right here. This right here has to be what power? If I want the first digit 4 for 4321, what does pow 1 have to be? Anyone? Or close? 3. Good job, Nick. Right? And good job, Sandy. Where'd you see line 79? Oh, well, I put that's to get the digit 4. Oh, wait, where'd you see lines? Oh, yeah, you saw it above the line.
It's defined on line 79.
Okay, I don't see where you're pointing to, though, but it's okay. Good job. All right, so this has to be 3, right, based on the previous file. Right, if I want the first digit, num digits minus 1 is going to give us 3. Right, so I need 3 to get the first digit. Right, so what I'm doing over here for pow 1 is I'm doing num digits minus I plus 1 to get me the first digit. That was the one way I could do it, with num digits and I. Because if I did num digits, if I did I is 0 in the first iteration, so it doesn't get me 3, right? So what I can do is I can take num digits, right, minus I plus 1. I plus 1 is 1. Num digits is 4. 4 minus 1 is 3. So that's how I got 3 over here. And then for pow 2, I just took I, because if I want the last digit right here, we did num digits minus 4, which is 0. That's 0, so I need 0 over here. I need 0 over here. So we already have 0. It's right here. So that's what we did over here. We just kind of matched what we got over here. And then all I did was I checked if the current digit does not equal the matching digit, right? If it equals a matching digit, I can't return true because we have to still check the insides, right? So I will only care if they don't match. If they don't match, return false. Now, let's say it never returned false, then we can return true, right? But only after we did all of our checks. If we make all of our checks, right, and they all matched, then we know that it was true, right? It's a palindrome at that point. So this could have been really confusing, and none of this could have made sense. Maybe some parts made sense, what's going to happen is you just have to kind of rewrite this problem on your own, right? You have to study this, and then you just have to redo it on your own. But you have to write the input and the output, right? You have to get used to writing the input and the output.
So what you're saying is you would write lines 96 to 105 first?
Yes, I would write lines 96 through 10 to 105 first. Yeah. And here's the thing, though. I mean, in that interview, right, like, it would be challenging, and I would have missed this part right here also, right? So maybe your interviewer would ask you, well, in what scenario would this not work in, right? So then that's like a challenging thing to kind of come up with on the spot. So in that scenario, you kind of have to like start plugging in numbers here, right? You have to start plugging in inputs and seeing where it wouldn't work, right? The log is a big indicator, right? So I guess like plugging in 1, plugging in 10, plugging in 100, 1,000, seeing where maybe it might not work right there with the log. But you might get this, you might not get this, right? I might not get this on the interview. Yeah, Sandy.
This is all covered right now, it's all written ES6, right?
This is all ES6, yeah. But ES5 would just be you replace the lets with vars, and you put a function is palnum parentheses n. So it would be very similar.
I think. Oh, yeah.
Go ahead, Nick. All right, so let me send you this file because it's changed a little bit. Oh, wow, cool. Oh, good job, Nadir. Crushing it. I'll put this in the file too. I'll give you credit. You'll be in this file forever, Nadir. And in my Dropbox. All right. Just take a moment, go through this, right? I would love nothing more than you guys just doing LeetCode problems, right? Your final project could be 100 LeetCode problems, right? And that could just be on your GitHub.
Did you say the final project would be 100 LeetCode problems?
It can be. You know. If you can do 100 LeetCode problems, then I think we've done our job.
More than progressive.
It's more than we can do. Right, just download the file. Rob, give me a thumbs up when you have the file. You got it? Cool. All right, so I'll just put timer up, 10 minutes. Just go through this a little bit with your partners. Does anyone online want a breakout room? Let's see, do I have my volume up? I do. Anyone want a breakout room?
No.
Okay. Yeah, in the next file, Nick, I go over the signed and unsigned numbers.
Okay.
Yeah.
Which file is
Well,
that?
I thought it was the next number, next file. 06.
Okay.
06, yeah.
This is what's highlighted. Yes. Yeah. Like push back on it.
Yeah, they're overlapping.
I can't scratch this.
Okay.
That's interesting. Oh. That's this one.
That's how you do progressive. Expansive.
Hmm?
I want to do some Rails again.
You're gonna do some Ruby on Rails?
No. I used to do it, but
Mhm.
so I completely forgot.
Yeah, there's Rails.
But I'm just wondering, how do you use? Are you using RVM?
I use RVM, but you
You,
could
ha-
use
you,
you could,
you have to use RVM, right?
yeah. So I have RVM right here. By these Ruby versions.
Yep.
Right.
So you got to use RVM so you can.
So you got
handle
different versions of Ruby. Yeah. And then yeah, dude. Any questions you have on Ruby?
Okay.
I've done it forever.
Because I want to do GraphQL with Ruby.
Cool. Yeah.
Yes.
There's a lot of Ruby jobs in the Bay Area.
Oh yeah,
A ton. Yeah. I mean,
I thought they're phasing it out, or I don't know.
I mean,
They're moving away from.
they'll
They can't, right?
if you're dealing with scaling issues,
Uh-huh.
then Rails isn't great,
Uh-huh.
right? I mean, it is hard to scale Rails. Although
But you can still.
Shopify's on Rails,
Yeah.
right? You just have to
GitHub is on Rails.
get,
They can't go away.
you have to get certain talent, right, to scale Rails because
Mhm.
you have to really understand Ruby well to do it.
Mhm.
So most Rails engineers, even me, I don't know how to scale really well. I mean, I can scale the servers.
Mhm.
I can do this the DevOps and the
Mhm,
sysadmin work. I can
Mhm.
because I can buy more servers. I can get a load balancer
Yeah.
and then just do that.
Mhm.
And that would scale it.
Mhm.
That's what most Rails engineers can do. But if you're dealing with like so much traffic like Shopify is dealing with, or maybe GitHub, right? Living Social also, right? They're dealing with a lot of traffic, so you kind of have to really understand Ruby and how the memory works because you don't have access to the memory directly in the code, so you have to like really work with the memory and stuff. And maybe there's something called JRuby,
Oh yeah, the Java.
right? With the JVM, right? So that might give you a little bit more access to Ruby. I don't know. So there's a lot of interesting things that you can do. You can also run processes in parallel too, if you want to in Ruby, but that's not something normal that you do in Ruby. So you can certainly do it. Rails is the best OO, I think, for object-oriented language. Rails is like hands down the best, right? If you have like a warehouse or a CRM, it is the way to go.
Oh, okay.
It is the way to go. I think Salesforce is Ruby. A lot of stuff they have is Ruby, which makes total sense because it's just a big relationship, right? Like there's all these relationships in Salesforce.
Yeah.
I mean, Josh would know more than anyone, but yeah. So
I want to try out, GraphQL with Ruby.
yeah, dude.
Because you can do stitching with GraphQL, so you just have multiple servers, then just stitch all of them.
Yeah, dude. This is how I learned in 2011.
Oh yeah, Michael.
In 2011, I read his book, and then I did his app. I did the app,
Yeah, me too.
and then I got a job.
Yeah.
Yeah, it was that easy back then, but he's kept it updated.
Yeah.
Ever since. It's crazy. Wonder what he's doing now.
He's doing.
You know, he has a PhD.
Oh yeah.
I don't know in what though. I don't think in computer science.
He's doing a lot of stuff now for learn enough to be dangerous.
Oh, interesting. What is
So
that?
he has JavaScript too.
Oh yeah, I remember Inoshi was such a cool project. So it didn't work out, right?
Mhm.
He just open sourced all the code.
Mhm.
It was like a complete social networking app built in Ruby on Rails,
Mm.
and he just open sourced the entire thing. It was so cool. Oh wow!
Command line, Git,
Wow.
yeah, everything. It's only $24, I think, or he's selling it for very cheap.
Yeah, I mean he's the way he explained things.
Yeah.
I think he's just amazing in terms of. Yeah, you know, action cable is something I just never bothered to learn. In Rails 5, you can have channels.
Mm. Oh yeah.
You can have channels.
So like multiple processes running.
Yeah,
you
but
can
it's not that good though.
Oh yeah.
If you're using it to scale, you should just use Erlang or you should
Or
use
Go.
or Go,
Yeah.
right? Or Elixir, one of those things.
Elixir is kind of hard to.
Elixir's hard.
Very,
no,
very wordy.
Erlang's hard. Erlang's hard.
Mhm.
Elixir's easy.
But it's too wordy. Right? Def module, def this.
I like it.
Oh yeah. Well,
I mean, there's Phoenix. The Phoenix framework is really,
yeah.
really good for Elixir. And all the Rails devs, they moved over to Elixir
Oh.
and Erlang and the Phoenix framework.
Yeah, I think that's the route, right? After Ruby,
They
you want to scale out, scale up.
you go
Erlang,
Phoenix. You go
Phoenix,
Phoenix if you want to really scale to, well, if you have like a lot of real-time processes,
Mhm,
right?
mhm,
If you
yeah,
don't have
yeah.
a lot of real-time processes,
Yeah,
it's not
that's
worth
right.
it. It's not worth
Yeah,
it. Like WhatsApp was Erlang.
Because it's real time, right?
Like the entire world's telephone systems ran on Erlang. Kind of nuts. It's like it was built to kind of handle that level
Mm,
of scale.
wow.
It's crazy.
Yeah, so I have to install RVM.
I have a Zoom meeting with one of the TAs. He is going to show. He made an app just like you did. He made like an example app with React, Redux, and Jest.
Oh, okay.
So he just made a sample app
React, Redux.
and Jest.
Oh, okay.
Yeah, so I'm just gonna
Yeah.
see what he
I'm
makes.
doing React Native now. React
Nice.
Native, Redux.
Are you doing React Native and Redux
But
together?
it's the same thing.
It's the same thing.
Yeah.
Yeah.
I just copy.
Copy and paste. Nice. Good job, man.
Yeah, if you're interested in Ruby, apparently both Ruby under the microscope, that's what's supposed to be so really good to understand how Ruby allocates memory. Just another book to read. I haven't read it, but yeah. Oh, shit. Yeah. Apparently. Meet some of the rats for you. Yeah, it's the word that makes it true to. No. It's just broken. This has happened. It's just very fast.
Oh, I see. So it makes it work.
All right, guys. Questions that came up when you were going over 05? Whatever you do, make flashcards, right? Make flashcards on how to get the number of digits, right? How to get the first digit, the last digit, second, third, right? make a flashcard for this specific problem, right? Explain it in your own words. We came across some terminology on Thursday. We came across a 32-bit unsigned integer. So we'll go over what a signed integer is and an unsigned integer is. So a 32-bit signed integer is an integer is just a whole number, right? Whose value is represented in 32 bits. Bits are zeros and ones, and or 4 bytes. Each byte is a character. Each byte can be represented in a character. Since there are 8 bits in a byte, right? 32 divided by 8 is 4. So it can be a string of 32 zeros and ones. It can be represented like that. Now, the signed part of the integer means that it can be both positive and negative, right? Like the range for how big or how small this number can be is it can be positive or negative. If it was unsigned, it can only be positive, right? And some languages, especially in blockchain, will have specific data types called UINTs, right? UINTs, where they can only be positive numbers, right? And the reason why they have had those specific data types is because if you want to represent shares in a company, you can't have negative shares. You can have a negative share balance, right? So that's why they have those specific data types. And it's a language called Solidity, which is used for the Ethereum network and for Hyperledger. But if you have a signed number, if you have a signed integer, it can be positive or negative, right? But because it can also be negative, right? One of the bits, one of the 32 bits has to be allocated towards the sign, positive or negative, right? And so over here, if you have a 32-bit number, 32-bit signed number, the lowest it could possibly be is 2 to the 31 minus 1. I mean, I'm sorry, the highest it can be is 2 to the power of 31 minus 1, and the smallest it can be is negative 2 to the 31. And if you add up all these numbers, you get 2 to the 32 minus 1, right? That's where the 32 is. Right? You have 32 bits. If you have a 32-bit signed number, the range is going to be 2 to the 32 minus 1. But because it could be negative or positive, right, the highest it could be is 2 to the 31 minus 1, and the lowest it could be is minus 2 to the 31 right here. And if it's unsigned, then it can only be positive, right? So the max is 2 to the 32 minus 1, and we need to subtract 1 so that the 0 is in the range, right? Because one of that, it can be 0 to 2 to the 32 minus 1. But the range is 2 to the 32 numbers, right? 0 is a number. So we have to account for that over there. So when people say signed or unsigned integers, right? Now you kind of see signed means it has to be positive, right? So if I say over here, let's go to the very bottom, test it out. All right, Quasro. Let's say I have an 8-bit signed number. What's the lowest? What's the highest, right? What's the range? What's the range of an 8-bit signed number?
2 to the 8 minus 2 to the 7.
Perfect, right? 2 to the 8th minus 1 is going to be the range. That's like how many numbers are between the lowest and the highest. Good. And then go ahead, say what's the lowest?
2 to the 7.
2 to the 7th, negative 2 to the 7th. And what's the highest?
2 to the 8.
2 to the 7th, minus 1.
Oh, it's
Yeah.
okay.
That's right. Yeah. And then let's do another one. We'll do a 16-bit signed number, Rob's row. What's the range going to be? Good. Excellent. And then what's the lowest it can be? Yep. Negative 2 to the, and what's the highest it can be? Excellent. All right, we'll do another one, but we'll do unsigned this time. So it has to be, it's gonna be forced. The lowest it can be 0. The highest it can be is something. Right? What's the range on a 16-bit unsigned number? It's gonna stay the same, right? Stay same range, right? Because it's gonna have, whether it's unsigned or signed, it's gonna have the same range. It's just signed numbers can be negative or positive, right? And so the range is 2 to 16 minus 1. What's the lowest it can be? If it's
0.
0, good. And the highest it can be is 2 to the 16th minus 1. Right here. I'm just going over terminology, right? Because if you see it again, you'll know exactly what they mean by signed or unsigned, right? If you don't know what it means and you're in a problem, it's very hard. You can't do it, right? If someone says, like, write a function to determine whether a number is in range for an unsigned number, I mean, how are you going to do that if you don't know what it is? It's just not going to happen. Yeah, go ahead, Sandy.
So unsigned, it has to be positive.
Yeah, unsigned has to be positive. I write that over here too. So unsigned can hold a larger positive value and no negative value. So it's going to be, yeah, so 0 is the min. And 2 to the number num of bits minus 1 is the max. And sign can hold both, is going to be negative and positive. So that's why the lowest it can be is going to be, or let's write a formula for it. The lowest is the min, 2 to the negative 2 to the num of bits minus 1 is the min. And 2 to the num of bits minus 1 is the max.
To account for 0, right?
To count for the 0, yeah.
Why is it 2?
Why is it 2? Yes, so let's go over binary. All right, so let's just, this is not binary, right? Because we binary is just 0s and 1s. So how would you read this number, Derek? Oh, this number right here. How would you just read it out loud? 1, 2. Well, how would you say it in another way? 123, right? 123, right? So binary, but binary, I mean, you can't do 1, 2, 3 because you can only use 0s and 1s. You can only use 0s and 1s. And it's interesting, like, there are quantum computers people are trying to make quantum computers. And the whole big thing around quantum computers is that you have more than just 0s and 1s, which is really crazy. But over here, if I have 1, 0, 1, right, this actually isn't 101. What this is, let's see, this is 2 to the 2 plus you're right, 2 to the 3. I think this is 10.
7.
Wait, hold on. Let me just make sure before I just lie to you guys. Hold on. 101 in binary is what? Binary to decimal conversion. 5, so I messed this up somehow. Oh wait, the first one's going to just be 1. 2 to the 0. Last digit is 2 to the 0. Second digit is 1 times 2 to the 0. The second digit is 0 times 2 to the power of 1. Third digit is 1 times 2 to the power of 2. So we add up all those. Right? What's 2 to the power of 0? 1. Good. 1 times 1 plus 0 times what's 2 to the power of 1? 2. What's 2 to the power of 2? 4. Right? 1 times 1, 0 times 2, 1 times 4, 1 plus 4. So this first, if you see a 1 here, you do 1 times 2 to the power of 0. If you see a 0 here, you do 0 times 2 to the power of 1. If you see a 1 here, you do 1 times 2 to the power of 2, right here. So what is this going to be in binary? 0. What about this right here? What is that going to be?
0.
Cool. Right? So whether you see a bunch of zeros or just a few zeros, it's always going to end up being 0, right? Because it's going to be 0 times 2 to the power of 0 plus 0 times 2 to the power of 0, 2 to the power of 1, 0 times 2 to the power of 3, right? It's going to keep going down to the power of 2. So this is binary right here. So that's why it's 2 to the power. Because over here, we're in base 10, right? But here, we're in base 2. And why are we in base 2? Because the possible numbers that each binary digit can be, is 2, right? 0 or 1, right? Why? Because the possible numbers each digit can be range from 0 to 9, 10 possibilities. Kind of nuts, but if someone ever makes something that has 10 possibilities, we'll be able to do like insane calculations really, really fast. Like you'll be able to guess everyone's passwords in the world like extremely quickly. Right? Because we're in binary right now, because all computers are binary right now, to guess someone's password could take like 20, 30 years, right? If it's really secure. With a lot of powerful computers, or thousands of years with lots of powerful computers running constantly.
The one thing on line 6.
Which one? I'm sorry. What line 6? Right here.
Yeah. Isn't 32-bit 5 bytes? It's 2 to the 5 is 32.
No. This is just representing like a unit conversion. It's just a unit conversion, right? So one character, like the character A, is actually 8 bits.
Okay.
Or digit. The character, like the digit 5 is actually 8 bits, right? It'll take eight zeros and ones to kind of represent that character. All right. What time is it right now? 11:24. All right, so I'm gonna go over the React app that we had on Thursday, and then we'll go on break. Right? that you are installed though. Yarn start. What is this? Okay, so it's the same app as we had on Thursday. The same app that we had on Thursday, right? We're gonna add some stuff to it, just some minor stuff, just to get you ready for your homework that you're gonna do when you come back from break. So I'm gonna open up 07 right now. I'm inside the index.html file. Let me just take the screenshot, send it over to you guys so you can see what I'm talking about. Right, so over here, I'm inside this index.html file. This file is where your entire React application will go, in this file. So Nick, you asked a good question, right? If you wanted to have just normal HTML and CSS pages, right? Where would you put them, right? You would, if your pages require data that changes, right? Then they don't belong in the public folder. They belong in the they belong as React components in the SRC folder, right? But if your pages are just landing pages, right? Meaning they're pages that are trying to convert customers into users, into paid users, then maybe they probably belong in the public folder, right? So because you could just throw HTML files in the public folder and they'll be served.
It sounds like EJS where you redirect to a page. Any component always just renders in the index.html.
Every component will render in the index.html, but if you have, let's say I have another file called landing-page.html. Then if you go to localhost 3000/landingpage.html, it'll be served. Right? Yeah. Plus share. Right? So on this line 29 is where your entire React app is going. Div ID root. This is where your entire React app's going in the index.html in the public folder. And then in SRC, we have index.js. And index.js on line 8, it's saying, find me the element with an ID of root, right? Find me the element with an ID of root, and then render the app component in that element, right? It's importing app from the app.js file, right here. It's importing app from the app.js file. If we open up the app.js file, right here, this is our app, right? This is what's being rendered ultimately inside div ID root of the index.html file of the public folder. So we select JSX. I installed a thing that would format it, right? I installed a plugin here called JSX. So that's why my colors look okay. So inside all of your JSX is, it starts with a T. What's it called? A templating language, right? A templating framework or language. And we've used another templating language or framework. What was that? EJS, right? We use EJS. That was another templating language or framework. So with JSX, all of your HTML stuff needs to go inside of a closing inside of an enclosed tag, right? So you just can't have a rogue paragraph tag right here. If you did, it'll throw an error. Failed to compile. Adjacent JSX elements must be wrapped in an enclosing tag. Right? You have to put that inside of it, and then it'll be fine. Right? All of your tags must go inside an enclosed tag. And it must go inside the return of the render function. The render function is part of something called the component lifecycle, which we'll explore more of that next week. It's part of the React component lifecycle. So inside the constructor, it's a class, right? It's a class. Inside this constructor function, we see this line super. You must have super here if you're going to have state. You must have super here. What does super do? Nick's out of the room. Good, right? It's gonna run the component class's constructor function. This is going to execute the component class constructor functions. That's what super does. And then I just said right here, this dot gravity equals 9.8 because gravity doesn't change, right? As far as we know, right? Gravity doesn't change. So, and it's certainly not going to change in our app. So we just put this dot gravity equals 9.8. Whereas we have a lot of other stuff. We have name, we have another name. And these can change, right? In our app, we have forms that can change the name and another name. And then we have students. It's an array of students. And this can change too because we're adding student objects into this array in our app. So that's why all of this stuff belongs in this dot state. So this is something part of all ES6 classes, right? You could put variables, you can put any variables you want, but this dot state is something very special in React, right? Anything that changes, any data that changes belongs in this dot state. Any data that does not change, you don't put in this dot state. Right here. So now let's go down into the HTML. And we see these two inputs right here. Right? When I update name right here, just take a look, right? So I'm going to put in William. Right? Notice what happens when I type William, right? W-I-L-L-I-A-M. Right? So it's changing this stuff in real time. I know I've said this before, but this is what makes React really good. We don't have to worry about updating the text on the page. We just update the variable, and then it updates the page for us wherever we're displaying the variable. Right? We don't have to do $, hashtag, whatever, .html or .text. We don't have to worry about any of that stuff. Right? It manages the state for us, the updating of the state on the actual JSX. And how is it doing that? Well, when we have this onChange thing, this is part of HTML5, right? And JavaScript, onChange. When this input changes, we're going to trigger this .update name. This .update name is right here. So we're going to use ES6 arrow syntax. If you don't use arrow syntax, it will not. You won't be able to find it. This .update name will not work, and update name won't work. So you have to use arrow syntax here. So inside here, right, we're just going to do this .set state name : event.target.value. Right, event.target.value is going to get us the value of that input, and we're going to update name in the state. So you never update state in React directly. You don't do this .state.name equals something. Don't do that, right? Why? Because React just does not like it. It'll just break everything. And it'll be hard to debug too, right? So you have to use this .set state. There's a set state function somewhere in the component, somewhere up through the class architecture. So whenever you want to update the data, you do this .set state. And that's essentially how update another name works also. So now let's take a look at right here. We have two students here, right? Derek and Rob. I'm gonna go ahead and put in Sandy. Doesn't have to be your favorite band, it can just be a band. Is that what you said? Cool. Yeah, so right here, now we have Sandy here, right? And if we take a look at our state, because I have React Developer Tools, a Chrome extension, we see 3 students in the students array. If I open that up and look at the last one, the Black Keys Fave Band, name, Sandy, right? So having React Developer Tools is very handy. So how did this work? Well, first, let's take a look at the form. Right, this is the form right here. And we have an ID student form. On submit, right, we're going to trigger the submit student function. The first input is the name input. The second input is the Fave Band input. So now let's take a look at submit student. We first do event.prevent default so the form doesn't submit and refresh the page. And then what we do over here is we get the name, event.target.elements bracket 0.value. You guys can use jQuery. A lot of people on Stack Overflow just don't use it, so I'm just not going to use it, right? You can use jQuery and it's fine. Fave Band was the second input, so we're going to do event.target.elements bracket 1.value. And then students is a brand new array. We're making a brand new array, right? So we have square brackets to be a brand new array. We're doing ... this .state .students. This gets us all of the students that are currently currently there. We're taking all of the elements inside of it and we're putting it right here in this array. And then we're making a brand new element in this array, right? And it's going to have a key with a name of name with a value whatever the variable name is set to. And then we're going to have a key called Fave Band with a value whatever the variable Fave Band is set to. And this is new syntax called this object destructuring that allows us to do this right here. And then we take this variable students, we pass it to this.setState, right? And what this is going to do is make a key called students and set it to the variable students right here. And this is how we update the students on the page. Now, over here we have a logo. We have a logo. The logo is inside the SRC folder, right? SVG files are super cool. It's code that represents an actual image. And you could actually, there are converters online that'll take PNG files and JPG files and convert it to code. And you could just have the code in your GitHub and you can version it, which is insane. Super cool. Okay, let's see what time. So what I can actually do is I can import that file, the SVG file right here on line 2, and I can actually just render it in my code right here. Let's see if this works. Might not. Okay, that did not work. Let's see. Probably because I have to do img. Oh wait, no quotes. Yep. See if that works. I'll put it at the top because that makes the most sense. There we go. Beautiful. Right. Now, if I wanted to do an on-click on this function, I would do on-click this dot click image right here. And I would put a function above the render function. So I would do click image, and wait, how was I doing this? Equals event.prevent default alert you click the image. Let's see if that works. Cool. So if you want to import an image, you just do import. You can give it any name you want right here from /logo.svg. And the dot slash, what does the dot slash mean? Kristen's row. Current directory, right? And so inside the SRC folder, you'll see logo.svg. Right, so over here, I'm doing image.image.src equals this logo. On click, trigger this image, trigger this function. And this is something you're going to have to use in your homework when you come back. So let me send you this right here, and then you'll go on break and you'll come back and you'll do an assignment. And then on Tuesday's class, we'll do the full stack app. We'll do the full stack app, and we'll also go over that last interview problem on LeetCode. And we'll try to make that a regular thing where we're just doing LeetCode problems, right? Just to get us in the rhythm of doing that. 7 React with image. Before you leave, just get this working on your computer. Wait, don't leave yet. Just get this working on your computer first. Oh, go ahead.
So if we want to put that image on there, we have to get that thing. That code.
Oh no, you can get a PNG file too, or a JPEG, whatever you want.
The other question is for just state, and that's what we're putting our objects in there. Values.
Yeah.
So that's already has some keys and values in there. If you don't know that already, so you can string. That's where it says name. String update.
So I would just, if you don't know the name and fave band, right? Just don't put anything in there.
So don't have this state.
Oh, I see what you're saying. So let's just say we have, let's say, classes, right? And we're going to have a bunch of class objects. We don't know what they're going to be. We just leave it an empty array. You for name for non-arrays, you would just do that, yeah. Great question. So I'll just wait until Nick has it running on his computer. So I installed Yarn. It helps. It's a bit more secure. It installs things faster. Well, you don't have to. You install Yarn once, but then you have to run Yarn install. For this example, I delete the node modules because it's a gigabyte. Sometimes. Oh, for this example, yeah, just run Yarn install in this example too. Oh, you would just stay in the room here. I'll just do it real quick. It takes a while for it to delete. That's how big it is. Yeah, wherever your package.json is, that's where you're going to run Yarn install. Right here.
I got you.
All right, guys, so come back at 1 p.m. and you're going to start 08 homework when you come back.
What?
Yeah.
It's an hour and 15.
I'm sorry, what 12:45. Thank you. Please come back. seats then. And start 08 homework.txt.
Just delete that package lock, not just
No, don't delete the package lock. Yeah.
because it showed me a warning that you have a package lock.
Hmm.
Not JSON.
Oh,
So I said yarn.
Just now, you're using NPM?
No, I was yarn installed, but there was a package lock.
Yeah,
Oh, you know what it was? I probably installed it with NPM first, and then it created the package lock file. Then I started installing with Yarn.
So
I guess you could delete the package lock. Yeah, I guess that's fine. Because you have a Yarn lock now. Yeah, that's fine. How much, man?
Have a good weekend.
Ah, moving. You know. Deal with all
Where's
that.
it?
Walnut Creek.
You're moving to Walnut Creek.
Yeah.
Why?
Just
You've had it.
no, I mean like raising our rent.
Where are you right now?
Right now in Soma.
Oh yeah. Somewhere in Walnut Creek. That's a move.
It's a move. It's a move. We're getting a car too.
Walnut Creek is nice though.
Yeah.
It's really nice, right? Like just no heroin. Just
It's almost no heroin. It's true.
it's almost no heroin.
I think always games.
So basically, that's the talking point for you.